name is Anna. I'm a courseware developer and trainer at Logarithm. In this short presentation, I'll review the role of metadata within Logarithm. Metadata is simply defined as data about the data. So first, let's review data. Log messages are generated from many different types of systems, and these log messages contain valuable data that describes some action occurring in the environment. Threats and risks arrive from many angles, and evidence of their existence can be found within this log data, but there's so much information to deal with that identifying the threats that really matter and responding to them in a timely manner is almost impossible. How can your security team quickly evaluate all of this data to identify threats and determine whether an incident has occurred or not? Logarithm can help. Log messages are the key component within Logarithm, and hundreds of these log messages are processed every second. Logarithm takes the raw log messages and makes the data easy to read and analyze by parsing metadata from every log message. A log message from a Windows server is shown here. The raw log message is made up of various pieces of information, and some of this log data is human readable, but in many cases it is not. Logarithm actively parses and breaks down the log messages into core components, identifying what kind of data the log message contains, the meaning behind the message, and the relative importance of the action described in the message. The data parsed from the log message is called metadata. Logarithm maintains a wide variety of common metadata fields that identify most data found within the different log message types. This is how the data about the data is converted into the same language. In the example above, vendor message is the metadata field assigned to the EVID data 540. By converting many different types of log messages from many different types of systems into a common language or common metadata fields, Logarithm has the ability to compare apples to apples and then to correlate data that otherwise may not have been relatable. For example, a Windows server and a Unix server both log data about user login activity. However, the data does not look the same and the log messages appear very different. By parsing data into common metadata fields, searching for that data in the mass of log messages is made easy using consistent terminology or consistent language. Because metadata is stored in a database using these common field names, it can quickly be referenced for more efficient searching and allows for in-depth reporting and analysis. Origin host and login are two metadata fields parsed from the log shown here that are often used in searches and reporting. There are three types of metadata in Logarithm. The first two types are parsed directly from the raw log message. That's contextual and quantitative metadata. Contextual metadata is usually text-based and descriptive in relation to the message. Examples of this type of metadata include login, account, sender, and subject, just to name a few. Quantitative metadata can be used for numeric comparisons. Examples include bytes in and out, size, and rate. In addition to parsed metadata, Logarithm derives some metadata from the logs. Derived metadata fields use parsed information and relate it to the Logarithm configuration information to provide additional context about the log message. Some examples of derived metadata include impacted known host and direction. Keep in mind that the lists shown here are only some examples, and there are many more metadata fields used by Logarithm. Two very important additional metadata fields are classification and common event. Every single log message is assigned a classification in a common event field based on the information derived from that log message. Classifications are used within Logarithm to help group log messages into easy-to-use common event types. All classifications are contained within three types: audit, operations, and security type messages. Let's look at the audit classifications. Some examples of audit classifications include account created, access success, and authentication success type messages. Common events are then associated with each classification to further describe the activity in a log message. So classifications define the broad range of activity, successful authentication in this example, and common events provide a more descriptive context for the log message. For example, under the audit classification of authentication success, the following common events are contained: user log off, user log on, computer log off and log on, service log off, and service log on. The act of authenticating successfully is being described in each of these common event types, give a better indication of what actually happened in a log message. For example, if a Windows computer connects to a network for the first time in a day, it will perform a computer logon type of event with the domain controller. If a user accesses the same computer, a user logon log message is created to indicate the successful authentication type activity for that user. Looking at the operations type classifications shown here, the common events occurring under network traffic include connection attempt, connection closed, connection lost, and connection request. Those are all common network traffic type operations events. Examples of common event types under the security classification shown here of reconnaissance include ping sweep, port scan, traceroute activity, and vulnerability scans. Logarithm is very powerful, and understanding how metadata is used will ensure your success. So let's look at using metadata. Because metadata is stored in a database using common metadata field names, it can be quickly referenced for more efficient searching and allows for in-depth reporting and analysis. Notice the metadata fields shown in these examples. You can see classification, common events, direction, user, and application, to name only a few. Metadata drives the interactions with the log data collected in Logarithm. Metadata is used by virtually all aspects of the Logarithm platform, from alarming and analyzing to searching and reporting. Logarithm is very powerful, and understanding how to use metadata will ensure your success. For more information, please visit logarithm.com.